Okay, we're taking a look at 11.1 systems of equations here. So we have systems of equations in two variables. We're just going to review that quickly here. You have three different scenarios. You can have either, oh, sorry about that. You can have either one solution where your two lines are intersecting. You can have no solution where the two lines do not intersect, or you could have infinitely many solutions where they form the same line. And then just to make note here on no solution, for no solution, you're going to end up with a false statement. So you're going to, if you're going to solve this algebraically, you're going to get something like this, 0 equals 5, where all of your variables are going to cancel out, but the, the numbers do not cancel out. And then infinitely many solutions, you're going to get a true statement. So that means that everything will probably end up canceling out when you do this algebraically, and you're going to get 0 equals 0. So let's review substitution and graphing and elimination here for our three systems to solving, or sorry, our three methods to solving our systems. So for substitution, you're going to solve for one variable in one of the equations. So here, I'm going to take this x and I'm going to add it to both sides. I'm going to get y equals 3 plus x. I'm going to plug that into the first equation for y. So I'm going to substitute into the second equation for this y here, because y is going to equal 3 plus x. So I'm going to have 3x plus 2y equals 11. And then I'm going to put the y in. I need a little more room here. So I'm going to put it in as 3 plus x equals 11. And then I'm going to work this out. So I'm going to bring down the 3x plus 6 plus 2x equals 11. I'm going to combine my like terms, 3x plus 2x, that's going to give me 5x plus 6 equals 11. And then I'm going to subtract 6. I'm going to get 5x equals 5. Divide by 5, and I'm going to get x equals 1. So I got my x value. Now what I'm going to do is go solve for my y value. So I'm going to go back to this equation here, y equals 3 plus x. And I'm just going to plug my x value in here. So 3 plus 1 is going to give me 4. So I have x equals 1 and y equals 4, and we're going to write the solution as an ordered pair. So 1, 4. Now looking at example 2, we're just going to take the same thing and we're going to solve it graphically. Okay, so we're going to graph both of these on the same line. I'm going to go ahead and let's see, for here, I'm going to add x to both sides. And that's going to give me y equals x plus 3. So I'm going to start with my y-intercept, which is 3. So 1, 2, 3, make a mark. And then I have a slope of 1 in front of that x. So up 1 over 1, make my points here. And then I will connect these dots with a line, somewhat like that. Okay, and then I have 3x plus 2y equals 11. That's going to be a little bit tricky here with our graphing. So what I'm going to do here is I'm going to find the intercepts, and that'll be a little bit easier. So I'm going to do the 3x equals 11 for the first intercept. And let's see here. That's going to be x equals 11 over 3, which is going to be 2 and 2/3, so 2.67 for our x-intercept. So I'm going to have to go 2, here's 3, so 0.67, maybe about right here. There we go. And then our y-intercept, we'll do 2y equals 11. Divide by 2. And we're going to get a y equals 11 over 2, which is going to be 5.5. Oh, we lost the other one. There it was. Okay. So 1, 2, 3, 4, 5, right in the middle, 0.5. So then we can go ahead and take this line and connect it. And we can see where these two intersect. And the graphing sometimes is not, especially when you do it by hand, exactly, but it looks like it is 1, 4. So this point right here, which keeps erasing on me. There we go. Okay. So that is the point 1, 4. And then if you are graphing that and you hadn't solved it algebraically previously, you would want to take that and plug that in just to check to make sure. And then let's look at another one by doing a system of elimination. Elimination is what we're going to take into the rest of this section when we look at systems of 3 variables and 3 equations. Okay, so what we want to do here is our goal for systems of equations by elimination is to get the number in front of the variable to be the same number, but opposite sides. Okay, so we're going to write here that our goal is same number, opposite sides. And we're going to do that by elimination, or sorry, not elimination, we're doing elimination. We're going to do that by multiplication, finding the least common multiple. So it looks like the y's are already opposite signs, so I'm going to go ahead and take these and make these into the same number. So the least common multiple of 4 and 3 would be 12. So then I would multiply the first equation by 3, because 3 times 4 would give me 12, and the second equation by 4, because 4 times 3 would also give me 12. So I'm just going to distribute this. So I have a 3 times 3x will give me a 9x. 3 times 4y, negative 4y, negative 12y. 3 times 1 will give me 3. Then I have 4 times 2x will give me 8x. 4 times 3y will give me a positive 12y. And 4 times 12 will give me 48. If I add all of these together, I have 9x plus 8x will give me a 17x. These 12s, they're going to eliminate. Negative 12 plus 12 gives me 0. And then 3 plus 48 gives me 51. I divide both sides by 17, and I'm going to get x equals 3. And then once you get one of the values, x or y, then you're going to take that and you're going to plug it back into one of the original equations. So let's say I do the second equation. So you can find the other variable. So 2 times 3 plus 3y gives me 12. Let's see, that's 6 plus 3y gives me 12. Subtract 6. I'm going to get 3y equals 6. Divide by 3. Y equals 2. So I have my answer here, 3, 2. Okay, let's take a look at another example, and we can go ahead and solve this using elimination. So let's see here. So let's go ahead and try and eliminate the x's. You have 3 and 6. The least common multiple would be 6, which means I don't need to do anything to my second equation, but I can go ahead and take this, multiply by 2. So 2 times 3x will give me a positive 6x. 2 times negative 2y will give me a negative 4y. And 2 times 4 will give me 8. When I come through here, here is what happens. My negative 6 plus 6 cancels, but also my 4 minus 4y also cancels. So this gives me 0 equals 7 plus 8, 15. Well, 0 does not equal 15. That is a false statement. So this is an example of a no solution. Okay, let's take a look at example 5. We go to eliminate, let's see, we can eliminate the y's. I will multiply both sides, or sorry, both first equation by 2. This is going to give me a negative 8x plus 4y equals 4. And then in this case, everything cancels on the left. 8 minus 8 is 0. Oh, that should be a 2 there. Sorry about that. Negative 2 plus 2 gives me 0. And then negative 4 plus 4 also gives me 0. So I get 0 equals 0, which is a true statement. So this is your infinitely many solutions. Or you could write this as negative infinity to infinity, because it is an interval where anything in that interval from negative infinity to infinity will work, any solution that you plug in. All right, a system of nonlinear equations. Let's take a look at an example of this here. So what we're going to want to do first is we are going to want to use substitution for this one. Okay, so the reason why we want to use substitution for this one is because it is a nonlinear system. Another thing that we could do is we could probably graph this, but I'm pretty sure from memory that graphing this is going to give us some non-whole number solutions, but let's just go ahead and take a look just in case. So I'm going to pull the graphing calculator over here. And I'll put these in. Let's see. 3x. So we can see this. 3x squared minus 2y equals 5. And x plus 3y equals negative 4. Okay, so let's take a look at this graph. Make it a little bit bigger. All right, so this is where you could go to find your solution. You want to see where these lines intersect. So they are intersecting at 2 points, -1, -1, and this one here looks like you're going to have some fractions. Okay, so for that, you would want to actually solve this algebraically to find that solution. Okay, so let's go ahead here and use substitution. So what I'm going to do is I'm going to solve for x since it is alone here. I am going to subtract the 3y from both sides. All right, so what I'm getting here is x equals -4 minus 3y. So I'm going to take that and I'm going to plug it into the first equation for x. Okay, so that's going to look like this. 3 times -4 minus 3y squared, so I'm going to do it twice. -4 minus 3y, because I'm going to end up wanting to multiply that out, minus 2y equals 5. So I'm going to multiply all of this out. I'm going to start with the inside here in FOIL. So -4 times -4 is going to give me a positive 16. I'm going to leave the parentheses there because I still need to bring that 3 down. -4 times -3y gives me a positive 12y. -3y times -4 gives me a positive 12y. -3y times -3y gives me a positive 9y squared. Let's go ahead and combine. Let's see, we've got 16 plus 24y plus 9y squared. Let's bring that 3 down. So 3 times 16 is going to give me 48. 3 times 24 will give me 72y. And then 3 times 9y squared will give me a 27y squared. Let's bring down this minus 2y. And since I've got this squared term, I'm going to bring this 5 over as well. I'm going to subtract it. So it's going to be a -5 equals 0, because this is a quadratic that we're going to have to solve and get the two solutions. All right, so let's put this with the squared term first. So you're going to have a 27y squared. You've got to combine like terms here. 72y minus 2y, that is a positive 70y. And then 48 minus 5 is going to give me a positive 43 equals 0. All right, so we can factor, I think we could factor this. I don't believe we can take out a GCF here, so the factoring might be a little difficult. So let's go ahead and just do the quadratic formula for this one. All right, so you've got your b, so -70 plus or minus the square root of b squared, so 70 squared, minus 4 times 27 times 43 over 2 times 27. All right, so let's work that out. Let me grab a calculator here. So we've got 70 squared is 4,900 minus, let's see, 4 times 27 times 43 is 4644. And that is going to give us 256. And then 2 times 27 is going to give us 54. So if we take this and simplify it, we've got negative 70 plus or minus the square root of 256 over 54. Now let's go ahead and see what the square root of 256 is. And that's a whole number 16. So this is going to be negative 70 plus or minus 16 over 54. And then we will break that into two equations. So negative 70 plus 16 over 54. That's going to give us negative 54 over 54. So that's negative 1. Okay, then we have negative 70 minus 16 over 54. That's going to give us a negative 86 over 54, which we are going to have to go ahead and see what that comes out to for a fraction here. We can reduce that. Negative 86 over 54. And that gives us a negative 43 over 27. Okay, so what we've gotten here is we have found the y values. Okay, the two y values for both of the intersections of our parabola. So we found these y values here. Negative 1 for the y value, and then the negative 43 over 27 is negative 1.593. That's what we have here. So now we want to find the x value. So to find the x value, you're going to take each of these, plug them back into the original equation here. Okay, so not the original equation. You're going to, well, actually, yeah, we could plug them back in right here to where we have x equals negative 4 minus 3y. Let's go ahead and do that. Okay, so the negative 1, that one's easy. X equals negative 4 minus 3 times negative 1. So negative 4 plus 3, we get negative 1. So we get an x of negative 1 here. So we have the first ordered pair of negative 1, negative 1. Okay, then we're going to plug the negative 43 over 27 in. So x equals negative 4 minus 3 times negative 43 over 27. And we're just going to put that in our calculator. So we're going to go negative 4 minus 3 parentheses negative 43 over 27. Okay, we get this decimal here, which will convert to 7/9. So we get our x value, and so our second ordered pair is 7/9, because that's our x value, and then the y value, negative 43 over 27. Okay, so that is your system of equations when you have a quadratic and a linear. Okay, the next one that we are looking at, let's see here, we have a word problem. So we have the number of text messages sent per month by smartphone users varies by age. In a recent survey, the average number of texts sent by two age groups, 18 to 24, and those 55 and over was 1134. However, the number of texts sent by 18 to 24-year-olds exceeded the number by 55 and over by 1,776. So we have to translate this into a problem. So the first thing you have is you have an average. So an average is where you add two things together and then divide by how many. So we are going to do 18 to 24-year-olds. We're going to let that be X. And we're going to have 55 and over. We're going to let that be Y. So the average of 18 to 24-year-olds was 1135. So if I add these two together and then I find the average, meaning I divide them by 2, this is my first equation, 1134. And my second equation, okay, because again, this is the average, add the two together, divide by 2, and then that's what you get. Okay, then the second one, you have the number of texts sent by 18 to 24-year-olds exceeded. So 18 to 24-year-olds is going to exceed 55 and over, so you're going to take 55 and over, Y, You're going to add 1776. So whatever they had plus 1776 equals the 18 to 24-year-old group. And then we can solve this. So let's go ahead, get rid of this fraction, just multiply both sides by 2 here. So you can have the total number of texts. So x plus y is going to be 2268. And then we can go ahead and find, let's just plug this x value in, which is y plus 1776. So that's going to go in for this x right here. We're going to get y plus 1776 plus y equals 2268. So we can do two things at once here. We can add these y's together, get 2y, and we can subtract the 1776. And that is going to give us 492. And then we'll divide by 2. And we're going to get 246. So that means the 55 and plus group sent, what was it again? 246 texts per month. Okay, and then the 18 to 24-year-old group is just y plus 1776. So that's just going to be 246 plus 1776. And that's going to be 2022. So 18 to 24-year-olds sent 2022 texts per month. Okay, now what we're looking at are systems of equations in 3 variables. So this is where you're going to have 3 equations, and you're going to have 3 solutions to these equations. These solutions can be one solution where all 3 planes intersect, and if you notice here, these are 3D planes, so we're not going to be graphing them. Infinitely many solutions would be where they all intersect on the same line. This is a no solution, where they do not intersect, and they form a plane. Okay, so again, for the infinitely many, you would get a true statement, so you would get like a 0 equals 0, and the no solution, you would get a false statement, so like a 0 equals 5. So to do this, here's our steps. So we're going to do this with this first example here. So step 1, okay, you're going to look at your 3 equations. You're going to eliminate a variable by adding 2 of your equations. So what we're going to do is we're going to add 2 and 3 together to eliminate a variable, because we can look at this quickly and see that we can eliminate these z's. Okay, so I'm going to take equation 2, 2x plus y minus z equals 2, and then x plus y plus z equals 2. I'm going to add them together. I'm going to do 2x plus x is 3x, y plus y is 2y. These z's will eliminate. 2 plus 2 equals 4. I'm going to label this equation A. Then the next thing you need to do is you need to use equation 1, because you have not used that yet. And you need to eliminate a z again. So I'm going to take equation 2, but in order to eliminate the z's, I need to multiply this by 6. Okay, so 6 times 2x is going to give me 12x. 6 times y is going to give me a 6y. 6 times negative z, negative 6z. And 6 times 2 is going to give me 12. Okay, then I'm going to add these together. This is going to give me a 15x plus 15y. My z's are going to eliminate. And 3 plus 12 is going to give me 15. This is going to be equation B. Once you do those first 2 steps, now you have a system of 2 equations with 2 solutions here. So now you can go back to what we did in the very first part of this lesson to do your elimination. So let's say here you bring down equation A, 3x plus 2y equals 4. You want to solve that. Okay, so let's go ahead and eliminate the x's. So I'm going to multiply, I'll multiply this equation by negative 5. So that's going to give me negative 5 times 3x will give me a negative 15x. Negative 5 times 2y will give me a negative 10y. And negative 5 times 4, 40. Okay, which means I'm combining with 15x plus 15y equals 15. So these will eliminate. I have 15 minus 10, that'll give me 5y equals 15. Oh, that should be a minus 20, not 40, sorry about that. Minus 20, so negative 5, which means I divide by 5 and I get my first solution here, y is negative 1. Okay, once you get your y value, go back to either a or b, plug it in, find your x value. Okay, so I'll go to equation A, 3x plus 2 times negative 1 equals 4. You have 3x minus 2 equals 4. Add 2 to both sides. That's going to give you a 3x equals 6. Divide by 2. And we're going to get x equals 3. So now you have your x and your y. So then to find your z, your remaining variable, go back to any one of your original equations, plug the x and the y in, then you can find your z. So you have x plus y plus z equals 2. So your x is 3. Your y is negative 1. We don't know z, but we know it equals 2. So 3 plus negative 1 is 2. Okay, and then that is going to give us, subtract a 2 from both sides. We're going to get z equals 0. This seems a little off to me. Let me check my notes here. Give me 1 second. I found what I did here. Okay, so if I go back to my x's, look at what I did here. I did 3 divided by 2 because I had already divided by 3 in my head, and I was trying to move quickly. All right, so 3 divided by 3, and 6 divided by 3 is 2. So our x value is actually 2, not 3. So that is my bad here. Did make a mistake here by moving too quickly. Okay, so my x value is 2, which means 2 minus 1 gives me 1. And then I subtract a 1 here, and that'll give me a z equals 1. So if I go through that and I did that and I got my answers and then I went back and I just plugged them into another problem, then it wouldn't work. So if you want to check that, always plug it into your other problem. You're going to write the answer as x, y, z. So this is going to be 2, negative 1, 1. And it is easy to check if you just go on your calculator quickly here. You have 3 times 2, and you can just put the line in like this, plus 9, parentheses, negative 1, plus 6, parentheses, 1. And then that gives you 3. And then you have 2 times 2 plus negative 1 minus 1 equals 2. And then we already did the last one. All right, so let's do another example here. So let's pick a variable to eliminate first. Right off the bat, when I'm looking at this, it looks like the y's are going to eliminate first from equations 2 and 3. So let's go ahead and do that. We just add these together real quick. Right from here, we're going to have 2x plus 5x will give us a 7x. These will eliminate. Negative 3 plus 1 will give me a negative 2z. And negative 23 plus 16, I believe, is 7. Negative 7. Okay, so that's going to be equation A. Then equation B, I need to eliminate my y, so I have x plus 4y minus 6z. I have to use the first equation because I did not use that the first time. And I can use either one of these. So let's go ahead and take the last equation here, multiply by 4 so we can eliminate the y's. So 4 times 5x is going to give me a 20x. 4 times negative y, negative 4y. 4 times z, positive 4z. And 4 times 16, I believe, is 64. 64. Okay, then let's combine these together. So x plus 20x is going to give me a 21x. My y's will eliminate. Negative 6 plus 4 is going to give me a negative 2z. And then 1, 2, 3, and 4 here, that is going to give me a 7, positive 7. And let me check. Okay, so now I'm going to take equations A and B, and I'm going to combine these together. Let's see, we've got a 7x. So I think for this one here, we can probably eliminate the x's. Oh, actually, no, the z's would be easier. So 7x minus 2z equals negative 7. So if I wanted to eliminate the z's, I can just change all the signs in my first equation, or the second one. Okay, that way these guys will be different signs, same number. This is negative 21 plus 7x will give me a negative 14x. Negative 7 minus 7, negative 14. Divide by negative 14, and I'm going to get x equals 1. All right, I have my x value. I want to find the z. So let's go over here to equation A. I've got 7x, so 7 times 1 minus 2z equals negative 7. This is 7, so let's go ahead and subtract that. So I have negative 2z equals negative 14. Then I'll divide by negative 2. Then that's going to give me z equals positive 7. And then we'll go back to any one of my original equations. Let's go ahead and look at that second equation since that's a positive y by itself. So I've got 2x, so 2 times 1 plus y minus 3z, 3 times 7 equals negative 23. So 2 plus y minus 21 equals negative 23. 2 minus 21 should give us a negative 19. And then if I add 19 to both sides, that is going to give me a y equals 4, negative 4. So I'm going to have x is 1, y is negative 4, and z is 7. And then, of course, I want to check that with my other equations. So let's look at the first equation. You've got 1 plus 4 times negative 4 minus 6 times 7, negative 57. Good. And then the last one, 5 times 1 minus negative 4 plus 7. And that should give you 16. Okay, that's it for 11.1.